Hello students, now in this session we'll start new exercise 3.3 of chapter 3, playing with numbers. Now in question number 1 there are two questions are there, that is, what is the sum of any two odd number? Sum of any two odd numbers. Okay, so what are odd numbers? This is the first thing that we have to understand. Odd numbers are what? Numbers which are not completely divisible by 2. Okay, the numbers which are not divisible by 2. So those are the odd numbers. So what is the first? What is the most smallest odd number we can say? The smallest odd number is 1. What is the next odd number that we can discuss? Is 3. What is the next odd number? 5, 7 and so on. Fine. So we have to analyze that if we add any two odd numbers, what would be the sum? So let us try. So if you add this 1 plus 3, what will be the sum? 1 plus 3 is what? 4. Again, if we add these two numbers, 3 plus 5, what should I get? 8. Again, we'll add this two number. 5 plus 7, what is what? 12. Now, what is the observation that we are doing? So, when we are adding any two odd numbers, the sum is always even number. Yes, these are all even numbers. So, that means we are getting even numbers, isn't it? And what is even number? The numbers which are divisible by 2. Okay, so even number is what? Even number is what? It is numbers which are divisible by 2. Okay, so what is the observation? We will say that the sum of any two odd numbers is always even number. So what? How to conclude this? So we'll write sum of any two odd numbers is even number. Okay, so this is how we'll conclude question number 1, sum number A. Okay, this is sum number A. Let's move on to sum number B. Now, in sum number B, they have asked, what if I add two even numbers? Now, again, we have already discussed which are the even numbers, the numbers which are divisible by 2. So, which is the most smallest even number we have? We know 2. What is the next even number? 4, then 6, then 8 and so on. Okay, so now what will happen if I add two even numbers? Let us check. So 2 plus 4 is what? 6. Again, what will happen if we add 4 and 6? 4 plus 6 is what? 10. What will happen if I add 2, 6 and 8? 6 and 8 is 14. So what is the observation, students? What is the observation? Observation is what? When we are adding two even numbers, what is the answer we are getting? Odd number or even number? Absolutely, it is even number. So we are getting even number. So according to all the examples that we have done, we can say that therefore sum of any two even numbers is even number only. Okay, so this is a conclusion that we can make for sum number B. This is sum number B, students. Okay, now let's move on to sum number 3. Question number 2 is true and false. Okay, so you have to do it by your own. So now let's move on to sum number 3. 3 is also very interesting sum. Now, question number 3, we have the numbers 1, 3 and 3, 1 are prime numbers. Okay, that is 1, 3 and 3, 1. These are prime numbers. Now, what is the prime numbers? We'll discuss it. Just let me read out the question. Now, both these numbers have same digits. Yes, now both these numbers are carrying the same digit. That is 1 and 3, 3 and 1. Same digits they are having, isn't it? Just the position, but just the values, place values are different. Now, find such pairs of prime numbers up to 100. Up to 100. Our target is to see up to 100. Now before that, we'll discuss what is a prime number. Now, prime numbers are most unique numbers, okay? Now, the prime numbers are those numbers which are divisible by 1 or by itself. So, I will write down the definition. Numbers which are divisible by only, the word only I have written, by only 1 or by itself. Okay, there is another definition of prime numbers, as we have already done factors. Okay, okay, you will keep this part. Okay, I will try to explain what is a prime number by just giving one small example. Now, why 13 and 31 is a prime number? Why? So, as according to the definition, the numbers which are divisible by only 1 or by itself. That is why 13 is a prime number. So 13 can be divided only by 1, isn't it? So if I divide 13 with 1, what is the answer? 13. And if I divide this 13 with 13, then I will get 1. So there is no other number which can divide this 13 completely, isn't it? So these are the only two numbers which can divide this 13 completely. When we are dividing with 1, we are getting 13. And when we are dividing this 13 with itself, that is 13, we will get 1. So this is the reason why these are prime numbers. The same goes for 31 also. Okay, so 31 is only divisible by 1 or by itself, that is by 31 only. So now our target is to check that how many more prime numbers are there which are carrying the same digits. Fine, which are carrying the same digits. So we'll write the statement as the prime numbers with same digits. The prime numbers with same digits. With same digits. Up till where? Up to 100. Fine. So what is the next prime number to 13? We'll check. What is the next prime number to 13? Is 13, 14, 15, 16 and 17. Yes. Now 17 is also a prime number. Now what will the reverse of 17? That is 71. Now we have to check that whether this 71 is also a prime number. Yes, it is a prime number. So the first pair we have found out is number 1, 17 and 71. So this is another pair which are prime number also and which are carrying the same digits also. Now what is the next prime number that we can say? The next prime number is 19, but 91 is not a prime number because 91 is divisible by other numbers also. That is by 7. Okay. So in this way, if I see, it will be a very long process. So I'm just giving you another prime number, that is 37. So 37 is also a prime number. And what is the reverse of this? The reverse of this is 73. So these two are again a prime number and they are also carrying the same digits. The last pair, those are prime numbers and even they are sharing the same digit, that would be I guess 79. So 79 is also a prime number, and what is the reverse of 79? That would be 97. So 97 is also a prime number. So these are all the pairs which are the prime numbers and they are sharing the same digits. Fine. So this is the solution of sum number 3. I hope you have enjoyed this sum, students. Now let's move on to the last sum for today, that is question number 4. Now in question number 4, what we have to do is write down separately the prime and the composite number less than 20. That is prime numbers less than 20 and also composite numbers less than 20. Fine. So we already know what is a prime number. Now what about the composite numbers? The composite numbers are what? The composite numbers are those numbers which are not only divisible by 1 or itself, but it is divisible by other number also. Fine. So that example I can give you as a 4. 4 is a composite number. Why? Because 4 is divisible by 1 also. 4 is divisible by 4, that is by itself also. And 4 is also divisible by 2. Fine. So that is the reason. What was the prime number? Prime number were those numbers which are only divisible by 1 or by itself. But composite number is what? The numbers which are also not only divisible by 1 or by itself, but it is also divisible by other number also. Let's take another example. That is suppose 16. Why 16 is a composite number? Because 16 is divisible by 1. 16 is also divisible by itself, that is 16. 16 is also divisible by 4. 16 is also divisible by 2. 16 is also divisible by 8. You see, so many numbers are there. Fine. So that is the reason they are called a composite numbers. So now your target is to see the prime numbers. The first target is to write all those numbers, all those prime numbers which are less than 20. Okay. So you write the statement as prime numbers less than 20 are. That is, what is the smallest prime number, students? Smallest prime number is what? Not 1, not 1. Never do this mistake. Okay, never 1. Because 1, you always have to see the prime number should have at least only 2 numbers, not less, not more. So 1 is only divisible by 1. So there is no 2 numbers which can divide this. Okay, because prime numbers are those numbers which have 2 factors. Fine, 2 factors. That means 2 numbers should divide that number, not less than that. And what are those 2 numbers? 1 and by itself. 1 is only divisible by 1. Okay, so it is only divisible by 1. So it is not carrying the second factor, isn't it? So that is the reason it is not a prime number. So we'll start prime number from where? 2. 2 is a prime number because 2 is divisible by 1 and by itself. That is 2. So first prime number is 2. What is the second prime number? We have 3, then we have 5, then we have 7, then we have 9. No, 9 is not a prime number because 9 is divisible by 1, 9 is divisible by 9, 9 is divisible by 3 also. So 9 is not a prime number. What is the next prime number? It is 11, and the next prime number is 13. And what is the next prime number then after 13? Check, check, check. It is 17, and finally it is 19. Because less than 20 we have to check. So these are all the numbers which are prime numbers less than 20. Okay. Now let's check the composite numbers. Let's check the composite numbers. Composite number. Composite numbers less than 20 are. Now we have to check those numbers which are not only divisible by 1 or by itself but by other number also. So the smallest composite number is what? 4, then 6, then 8, then 9 also. It's not that all the even numbers are the composite numbers. Okay, events. Odd number is also the composite numbers. Okay, 9, then 10, 12, not 13, 15, 14, then comes 15, then comes 16, then 18. So these are all the composite numbers less than 20. Okay, so what we have learned today, we have learned so many things today. Okay, what is a prime number, what is the composite numbers, okay, what are the what are odd numbers, what are even numbers. So these are all very, very important numbers that will play a very important role in your higher classes also. Okay, so that's it for students. That's it. So thank you. God bless you all. Stay blessed and take care.